Hi everybody, my name is Stefano and welcome to another video on this SQL tutorial series dedicated to SQL concept and theory. In this video, I'll give you an introduction to the main database systems in the realm of relational databases, which are OLTP and OLAP. More specifically, we will see what they are, what are their main differences, and what's their use cases. So, let's get started. As mentioned in a previous video, we have defined relational databases as a system for storing and managing data organized into tables. Let's now introduce the concept of OLTP and OLAP database system and their main characteristics. Online transaction processing (OLTP) and online analytical processing (OLAP) are two different types of database systems, each optimized for different types of workloads and purposes. OLTP systems focus on handling a large number of short, atomic transactions efficiently, ensuring data integrity and quick response time. A typical example is when placing, modifying, or deleting an order on an e-commerce platform. In this case, the challenge is not handling the amount of data involved in each transaction, as they are typically very small, but ensuring that the response time for each transaction is almost in real time, considering the potential large number of transactions occurring simultaneously worldwide. OLAP systems, on the other hand, focus on providing fast query performance for complex analytical queries on large datasets, often involving historical data. This environment is ideal for analysts where the main challenge is the opposite of OLTP, a smaller number of transactions but involving high volumes of data from which extract insight and influence company decision makers. Now that we understand some of the main differences behind OLTP and OLAP systems and their typical use cases, let's explore the main factors that differentiate these two. Returning to the e-commerce example, let's say we want to track which books we sold, when we sold them, and to whom. One way to accomplish this could be to store all this data in a single table like this. However, some of the main problems with this solution are that repeated values or redundancy might create several issues, such as increased needs for storage and associated cost, reduced query speed, and potential inconsistencies, which occur when, for example, a value is mistakenly updated in one instance but not in all instances. To avoid these problems, we can use a technique called database normalization, which is specifically used for eliminating redundant data. By storing the data in multiple tables indeed, and adding the opportune keys where necessary to let the tables communicate to each other, we can efficiently eliminate the redundant data and avoid the problems mentioned above. This process can be repeated multiple times until the database is fully normalized, which means that the data cannot be further split into different tables. Indeed, for instance, continuing the normalization process, we could add two more tables, author country and sales, where to store the respective types of data, having so 4 tables instead of 2. Even though we will not cover the entire process of normalization at this stage, it is important to understand that the more we go through the process of normalization, the more tables will be created. And while these structures work very well for writing data into our OLTP database, that's why OLTP databases are usually fully normalized, it doesn't work very well when we want to read data from it for analysis purposes. This is because analysis often involves large amounts of data taken from different tables, and the more tables we have, the more joins we need to perform, which are computationally expensive. So if the number of joins is the main problem that slows down our queries, what's the best way to solve it? A very efficient way to solve this problem is to use star or snowflake data modeling techniques, which incorporate a certain degree of denormalization. Denormalization is indeed the reverse process of normalization, which essentially involves combining tables to reduce the number of joins required for queries, thereby improving read performance. Star and snowflake data modeling are very important concepts which will be discussed in a dedicated video. However, for now, it is important to understand that using techniques involving denormalization are also very important as, despite some redundancy, these techniques bring significant query performance improvement which are particularly useful in OLAP systems. So, if at this stage you are wondering which system to choose between OLTP and OLAP, the best answer is it depends on the business requirements. Businesses such as e-commerce and banks, indeed, due to their nature, they need both types of systems. On one hand, indeed, they need to process customer transactions in real time with OLTP systems, while on the other hand, they need to analyze large amounts of data for analytical purposes using OLAP systems. One of the best ways to achieve this result is using an ETL process, which stands for extract, transform, and load, which involves extracting data from one environment, such as an OLTP database, transforming it as necessary, and then loading it into an OLAP database. This way, we ensure to have the best of both systems. So, thank you very much for following along till the end, and congratulations on completing another step towards a career in data analytics. In the next video, we will go through the SQL commands with a special focus on DML and DDL commands, explaining what they are and what they are used for. If you enjoyed this tutorial, please like the video and subscribe to stay up to date with the latest releases. As always, if there is a specific topic you'd like me to cover, please let me know by leaving a comment in the section below. I hope you found this tutorial useful and I look forward to seeing you in the next video.